Hello guys, I am Mathangus and this is not a copy channel of Mathango, but I did not know any name, so I named Mathangus. So today we will discuss upon some general results for conic curves on s is equal to 0, t is equal to 0, and means in conic curves and in conic curves in general, not specific that we will dive into the conic curves. No, that's the general results. And a pole and polar, right, which is very important in circle, right? In circle it's the most important topic, and basically I am covering here for circle, right? So let's start. So first of all, let's understand what is s is equal to 0. S is equal to 0, what does this mean actually? So actually, what is s? S means you have a general 2-degree homogeneous equation, which is ax square plus by square plus 2hxy plus wait plus 2gx plus 2fy plus c is equal to 0, right? This is the general equation of any curve, right? Homogeneous 2-degree equation. So in this, the thing is, here I am considering any curve, not only that it is a circle. In a circle, what are the conditions? The conditions are h should be equal to 0 and a and b should be 1, right? They should be 1 or equal. If they are equal, a is equal to b, then we will divide it wholly and we will get this coefficient 1 and 1, right? So h is equal to 0 or this 2 has to be 1 in circle, but this is any general curve. Now what you do, this is equal to 0 is the equation of the curve, right? Equation of the curve, but this is in general an expression, right? An expression, right? This is an expression. Now what I say is, you put this expression equal to s, means this expression is s, not that this equation is s, but this expression is x, not equal to 0. Till this I am telling, till this is the whole expression. Equal to 0 becomes an equation, right? So s is equal to uh, basically ax square plus by square plus 2hxy plus 2gx plus 2fy plus c, right? Now we come to the point. So first of all, general result that for a circle, tangent, length of tangent, right? Length of tangent is equal to root s1. Now what is s1, that I will explain now. Okay, so now to relate with it, like what is the use of it, I'm giving you. For a circle, length of tangent is equal to root s1. Now the proof I am not giving, but the proof is there, obviously existing. How to prove is very simple actually. Okay, we will not go on that, but in some other video maybe I can discuss, right? So now let's talk of s1, right? What we denote is here s1. I'm saying s1. What is this s1? So actually s1 is equal to s of p. Basically you tell that this is s, right? Now you have a general point which is p, point p. What is that point? P means any point. Let's say this is the curve, right? And here is the point P, and with respect to P, with respect to this, with respect to P, I will write this equation with respect to P. That means S1. With respect to P, I am writing this expression. Basically with respect to P, I am writing this expression, right? Now let's say this P's coordinates are x1, y1. As I said, with respect to P, that means in x and y we will put x1 and y1 because its coordinates are x1 and y1. So A x1 square plus B y1 square plus 2h x1 y1 plus 2g x1 plus 2f y1 plus c. Now first of all s1, so this is s1, right? x1 y1 means could be like anything. This can be 2 3, right? Any experiment, any variable, right? 2 3 or anything, right? With respect to that, you will put this coordinates in this equation respectively. Now this will give you s1. But now let's proceed to the results. What we will do with this? Okay, no, not now results. First let's define t. So you have written s1, right? Now I'm making a short video, so I'm not detailing the things. So what is t? I have written t is equal to 0. So s is equal to 0, you can get it. What is s, right? But what is t then? What is t? So t is basically an expression where t is equal to basically an expression in which you replace x1 by means x by, so let me write freshly. So you have s, right? You have s as an expression. Now here you have a term x square, x square. You replace this by x1. And what is this x1? This x1 is p, right? I have written x1, right? So with respect to p, basically this is what t's equation. Basically in Hindi I'm writing t ka equation with respect to p, right? मैं ये लिखने की कोशिश कर रहा हूँ. So this is what I want. X square to xx1, you will convert x square to xx1, y square to y1, and then x to x plus x1 by 2, and y to y1, y plus y1 by 2, and c to c only. C will not change, right? So this is the general format. So now how can we say this? Now what is the use of it? Now I have defined s and t. So basically let me first write what is t. So t is basically equal to axx1 plus byy1 plus hxy1 plus yx1. Oh sorry, I have not written it. So basically for xy it is xy1 plus x1 yx1 divided by 2. So this is the general format. Now if you write it, you will get this plus g x plus x1 plus f y plus y1 plus c, right? So this is the general obtained equation. So t and s we have defined. Now let's go for the general results. So the general results goes like this. So if there is a point P on the curve, basically I am saying this, that this is the curve. Let's say any curve, and here is a point P on the curve, right? If it is on the curve, then that means s1 is equal to 0 is the equation for what? Equation for what? Equation for the circle with respect to P. Basically equation of circle, equation of curve, equation of curve with respect to P. I am using the word equation, not expression. I am using the word equation of the curve with respect to P. With respect to P. Now let's go for second point. Now there is the P. Now how to draw tangent? Tangent is basically from this point you draw a line which is perpendicular to its normal. Basically, if there is a center, let's expect like a circle, right? Circle, because we are discussing for circle, so let's go for circle. That this is a tangent. Basically from center it makes 90 degree with the this is the normal, so basically it makes 90 degree with the normal, right? So that we will cover in tangent and normal. So this is s1 is equal to 0, but what if we have to find the equation of tangent? Equation of tangent, equation of tangent, I need this. For this, not for only circle, for any curve, for any curve it is t is equal to 0 with respect to P. Understood this? This is the meaning of t is equal to 0. Equation of tangent for any curve. For any curve t is equal to 0 with respect to P, if we write, which is this. Okay, this is only with respect to P. Basically x1 y1 are the coordinates of P. X1 y1 are the coordinates of P. Okay, so this till this we have understood. Now let's move to the next equation, which is if a point P is inside the curve. So if the result 2, this is result 1, result 2, in this I will say that there is a curve, and point P is inside this curve. Point P is inside this curve. Then there are many chords to this. This is a chord, right? This is a chord. This is a chord. Okay, this is the chord which is passing through P, and chord means to join any two points of the curve. Chord means to join any 2 points of the curve, right? Any two points of the curve. So there can be many chords, right, from passing through the chord, but there is only one chord which gets bisected because of P. Basically, if I say this chord is AB, right? AB is the chord because A is the point on the curve and B is the point, and I'm drawing this. So basically I'm saying there is only one curve, there is only one line which is bisected, one chord which is bisected by P. If that is bisected by P, that is bisected by P, that is only one chord. If there is only one chord, how can we find this chord? This is through these relations T and S. This is why these are too much useful actually. So how to we find this chord which is getting bisected by this point P? Basically AP is equal to PB, length. In length, line segment AB is equal to PB. The lengths are equal, right? So how to get this one? So we have an expression T, and you have to put it equal to S1. This is the general result. Now don't ask me for proof. I'm not giving here the proofs, I'm giving here the results. So T is equal to S1 which is with respect to P. This is the equation of this chord. Okay, this is the equation of the chord. Equation of the chord. Equation of the chord. Right. T is equal to S1 with respect to P. Right, with respect to P. Now let's get the next form. So I guess so you have got that form. Now the next form is ahead of you, that is we have to write. So there is a curve like this. Result theory. This is a curve, and we have a joint equation of chord. Basically this sorry. Hmm. Yeah, let's start it. So basically a curve is there. And then there is a point P outside the curve. Point P outside the curve. That was inside, and from inside you cannot draw tangents, right? Here there will be a case of tangent, so that is outside the chord. Now what we do is, from any point outside any curve we can draw only two tangents to the curve, right? So let's draw those two tangents. So let's say here it is it is making contact at A from the curve to the curve, and here it is making contact at B. Then this is known as chord of contact. And this two are the tangents. Right? now so we have with respect to P. Now I have two things. One is chord of contact. How to find the equation of chord of contact means this chord is chord of contact, where two contact points from the P. If you draw two tangents from P, there are two contact points, and if you draw the line, that is chord of contact. So the chord of contact, how to find the chord of contact? So basically you have expression T, and that you put equal to 0 with respect to P. If you do this, you will get chord of contact, right? Then if you have to find the of chord joint equation of chord of tangents, then we will get ss1 is equal to t square. Basically ss1 is equal to t square will be the expression. Basically what is the now you need to understand ss1. I explained you s1 is basically with respect to P, and T is basically with respect to P, but this S is general curve. Basically that is not with respect to P. Basically what is the general, how can I write it? It is basically x square plus y square plus 2hxy plus 2gx plus 2fy plus c, right, times x1 square plus y1 square plus 2h x1 y1 x1 y1 plus 2gx1 plus 2fy1 plus c is equal to T. And now you can write T's equation. I had told you earlier, T square. So with respect to P, this also with respect to P. T is always with respect to anything, right? So No, not yeah, always how I have taught you, that is always with respect to P only. So with respect to P, you have to write this equation, and this equation is the joint equation of chord of tangents. Basically, joint equation of chord of tangents. Basically, what am I saying is, joint equation of tangents is much better. Joint equation of tangents, basically this joint equation of this is the is this, right? ss1 is equal to t square. S is basically the general curve, and this is respectively, and P is x1 y1, right? So you have understood till this part. Now let's get the next ones. So next ones, now we have pole and polar. This general results ends here. Now we have pole and polar, and that is quite an interesting part. First, for that you have to understand what is locus. What is locus? Locus is basically path followed by a point. Followed by a point. Now, how can you know path followed by a point? Now I am giving you an example, right? By that you will understand. Basically, I am saying that there are 2 points, A and B. And I am saying there is a point C there. So the question is there are 2 points. There are 2 points. There are 2 points. 2 points. Okay, I will not write this much. Okay, the question is there are 2 points, and there is any point. I'm not specifying. I'm generalizing this point. Let's say CXY. If I draw a line from A to B, this is the question. From A to B, if I draw the line, and if this line, this point C makes equal angle with A, basically I am saying this is theta. Let's say this is the acute angle, right? Acute or obtuse, whatever it can be. Okay, let me define the question first. So it makes equal angle with both of them. Basically, if I join from C to A, this angle is theta, then this angle is also theta. This is the property I am saying of this point, that this point makes, if I join from C to A, then it makes here theta, and here is also theta, right? So this much you have understood, and this is an acute angle. Both of them are acute angle. I am saying about the acute angles, right? So by vertically opposite angle, I can say also this is theta. Then if that is theta and this is theta, then you can understand this, that these two sides are equal, because the base angles are equal. Then I can say yes, this is an isosceles triangle. This is very simple. Now I want to draw a triangle. And then I have a wish that I draw a triangle, and then I will see properties, right? So these two sides are equal. These two angles are also equal. So how can we predict? That which one is which one? So actually what you do is you put here a perpendicular. Now I will show you magic. You draw perpendicular to the base. Now do you see this is AAS. Do you see this property AAS or RHS? However you do, these two triangles ABC, let's say this is D, so ACD is congruent to BCD, right? Now now if you understand ABCD, then I can say AD is equal to BC. AD is equal to BD. Now it struck me that if this C is here, I have made this C variable. Basically I am saying this is xy can vary, but if it varies, what is the path it follows? Let's understand that. So do you accept that the property now held is AD is equal to BD? AD is equal to BD. And do you understand that perpendicular can be only one to the base? Basically from this point to this point there can be only one perpendicular. And only with this property only AD is equal to BD can be operated. Basically I am saying ki AD is equal to BD. If you accept, then these two angles has to be 90 degree, because AD is equal to BD will give SAS congruency to both, right? You understand? AD is equal, now I have result AD is equal to BD. Now this will give you SAS congruency. Let's say I am neglecting 90 degree I am neglecting. I am saying the property this C will have is AD is equal to BD. This I have operated. Now AD is equal to BD. Because of AD is equal to BD, I can also say this will follow SAS property, and then it's always that it will make 90 degree with the base, because 2x is equal to 180 degree and x is equal to 90 degree, and 90 degree to the base is only 1. If it's only 1, then there is only 190 degree to the base. So basically this point has to stick to this perpendicular only, this perpendicular line only. Understand that? Means let's say D, so let's say this C was x1 y1, and now this is x2 y2. Now only, okay, these two angles will be, let's say, phi and phi. Now these two, now this point will be on this line only, because there is only one perpendicular, and because of it only AD is equal to DB is possible. So I can say that it will follow the variable point will follow this line, will have all the points on this line, and this line is the perpendicular bisector. So the answer to this question is, what is the locus? Locus is basically the path of the points, path of the variable points. Basically you join all the variable points which are formed by the condition is basically locus. My hands are slipping. Locus. So this is the locus. Now let's come to pole and polar. Now you will understand pole and polar. What is pole and polar? Pole and polar. What is this? Pole and polar. Pole and polar is basically, I have said that there is a curve. Okay, there is a curve, and in that curve there is a point P outside the curve. Now what I say is let you you fix this point, fix it. Basically you fix this point here, it will stay here only. It's not a variable point, not a variable point, but I have some variable chords passing through this. Basically from this point to this point, if I want a chord, this is a chord. Okay, now this is a chord. Remember, this is a chord means this line segment is a chord, or this line is a, so this segment is a chord. So basically I can pass many variable chords through this point. It's a little curve, but okay, variable points, right? Okay, now from these 2 points, let's say A and B, so I have taken any one of the chord and that has intersected in 2 points A and B. Now from these 2 points there can be one I can draw two tangents, right? Two tangents. So one from this point, making this a contact, the point of contact for this tangent. So one tangent I can draw from this point, and from this point, what is the equation of this? T is equal to 0. So what is the equation of this? T is equal to 0 with respect to A, with respect to B, right? T is equal to 0 with respect to A, T is equal to 0 with respect to B. But here A, B is not given, so that will not work. Now you will say joint equation, but I will say this is also not given. This point is also not given. No, in that I had been given this point. Okay, that's the problem. Now this is a variable chord, right? Variable chord. So I will say that the intersection is X. X1. Now if I join these two, let's say this is C and D. Now I draw tangents from these two. I draw tangents from this two, then I will get the intersection point here, x2. So basically the intersection point is also varying with the varying point of contact. This you agree, right? Now the same question I have with respect to the condition, what is the path followed by the point, that is the locus of intersection of the tangents. This is what I want. Now if this is what I want, now you have to listen. Now what I do is basically I draw a clean diagram. So here is P, and now I draw any one curve and I will generalize it. Okay, AB, and this is point x1. So let us say that this is hx. Now this is a fixed point. Let us hold x1 y1 as this, and this is hk. Now if I say this is hk, the variable point, h and k are variable point, h and k variable, x and y, x1 y1 constants. If x1 y1 is constant and hk is variable, then you see that the if we draw the two tangent, okay, draw this as tangent. Basically this is a tangent. Okay, remove this is a tangent and this is a tangent. Basically, okay, you have understood that this is a tangent and this is a tangent. Now what I do is, you just see, now I need the equation of this chord of contact. This is chord of contact because these two are contact points, and if these two are contact points, I need the chord of contact. Now I write this chord of contact with respect to this variable point. Basically how I can write T is equal to 0. I had taught the chord of contact equation is T is equal to 0 with respect to a point outside the curve. So T is equal to 0 with respect to x, with respect to x1. But now what you see is this will also satisfy this point. This line, this chord of contact will also satisfy this x1 y1. Now the thing is I am saying T is equal to 0 with respect to x1, which is with respect to x1, and with respect to P also, because P is also satisfied through it, right? So I have to satisfy P also in that equation, because this is the line in which I have to satisfy P also and this also. So and then how can I get this HK? This is your understanding. Okay, let's leave with respect to P for now. I have this. My main aim is to find locus of intersection of the tangents. Now I have to find a path for HK. Basically, if I find the path as h some constant, let's say the path for the, I'm just saying, right, the path for the variable point is h square, h square plus y square is equal to let's say 36. Then what is this what is the locus of h and k? What is the locus of the h and k? What is the locus for this point? Is a circle, right? Because this is a circle's equation, circle. Now what we do in this type of things is we generalize it, because we need the path. We do not need this specific point. I need the path, so I generalize it into x square plus y square, because it will vary, and when I let x y, then I vary it. When I say fixed, so I let it x1 y1, because these hk's are varying it, so I will say that I will put h is equal to x and k is equal to y. Does not denote that h should be equal to x axis and k is equal to y axis. I'm letting it as variables, h to k and k to y, because these are variable points. Similarly, just an example, right, just an example, but t is equal to 0 with respect to x1 I have. So basically I have an equation in h and k. Now I will replace it by x and y, right? But I have to, I have another information that this will satisfy this also. So I will put x1 y1 in the equation so basically you need to understand that first I will replace that I will do t is equal to 0 with respect to x1. So basically I will have some time of this formation, no, xh plus yh plus yk plus let me write it, plus h okay, to hg, right? Okay, let me write it differently. H dash k dash, let's hold this. Okay, h dash k dash, because 2gh, right? So there you will confuse. So xh h dash y plus y. Okay, here it's becoming chaos, so let us write different page. Basically first I will write t is equal to 0 with respect to x1 to get the expression of chord of contact. Basically that will be x h dash plus y dash, sorry, y k dash plus h x h dash shit, x k dash plus h dash y plus f x plus h dash plus g y plus k dash, okay, plus c is equal to 0. This is basically t is equal to 0 with respect to k. Now I say that I have to find a general equation for h and k. So my main motive is to get out of this constant, because these variables are not at all necessary for me, x y, because these are unnecessary variable. This is not giving me the path of these points. These are unnecessary variable. X and y for this instant, this is an unnecessary variable. These are the variables which I want, which I need to know the 9, or I need to know the path of these points. I do not need to know the path of x and y. So I will put So basically P, which is x1 y1, also satisfy this. So if that satisfy this, then x1 h dash plus y1 k dash plus h x1 k dash plus h shit, here it should be yeah, सही plus h dash y1 plus f x1 plus h dash plus g y1 plus k dash plus c is equal to 0. Basically this is the fun, right? Now if you have this thing, is very easy, this is very easy actually. Now I need to have the path of h dash k dash, so I will replace h dash k dash with x and y. So x तो बेसिकली x1 तो हम इतना तक आ गए थे x1 प्लस, अब जैसे हमें h डैश के डैश में रिप्लेस करना था, सो y1 प्लस h x y1 yx1 प्लस f x प्लस x1 प्लस g y प्लस y1 प्लस सी इक्वल टू 0. तो ये हमें क्या दे देगा, ये हमें पाथ दे देगा ऑफ दी बेसिकली लोकस दे देगा ऑफ दी इंटरसेक्शन ऑफ टेंजेंट्स. समझ आ गया? तो बेसिकली अब तुम अगर देखोगे, अब देखो इस एक्सप्रेशन को ज़रा हम इससे कंपेयर करते हैं ना. सॉरी क्या खुल गया, तो हमारा फिजिक्स का चीज़ है. सॉरी हाँ इधर पे. तो बेसिकली अगर हम इस चीज़ के लिए अगर हम देखें तो बेसिकली हमने लिखा होगा t इज इक्वल टू 0 विद रिस्पेक्ट टू p वाला कहा गया ये. हाँ, t इज इक्वल टू 0 विद रिस्पेक्ट टू p. अगर आप देखते हो इसमें भी सेम ही एक्सप्रेशन है, एकदम सेम एक्सप्रेशन, ब्यूटीफुल सेम एक्सप्रेशन आपको दिखता हुआ इधर पे ही. ब्यूटीफुल एक्सप्रेशन आपको दिखता हुआ, ये सेम ही एक्सप्रेशन आप देखो, सेम ही एक्सप्रेशन है. x1 प्लस y1, इसमें भी देखिए x1 प्लस y1, x1 प्लस y1, x प्लस x1 y प्लस y1, x प्लस x1 y प्लस y1. सो बेसिकली आई कैन से दिस इज t इज इक्वल टू 0 विद रिस्पेक्ट टू p, क्योंकि p ही तो था ना x1 y1 जो कि मैंने इधर पे पुट किया x1 y1. समझ लो, मतलब इधर पे जो x1 y1 आया था वो तो p के वजह से ही आया था ना, x1 y1. तो ये कोई पॉइंट था जिसकी वजह से x1 y1 आया था, और वो पॉइंट किसी p या a या जो भी हो जिसके रेस्पेक्ट में मैं लिख रहा था उसके वजह से ही तो ये x1 y1 ऐसे करके आया था. मैं जब t इज इक्वल टू 0 लिखता हूँ मैं हमेशा विद रिस्पेक्ट तो लिखता हूँ, लेकिन इस समय जब मैं कोऑर्डिनेट x1 y1 देख रहा हूँ मुझे पता है x1 y1 क्या है, हमारा कोऑर्डिनेट किसका है, हमारा कोऑर्डिनेट p का है. तो एक्चुअली ये घूम फिर के किस में आ गया, t इज इक्वल टू 0 विद रिस्पेक्ट टू p. इसका लॉजिकल रीजनिंग नहीं है, इसका ये रीजनिंग है कि मैं इधर से घुमा के ऐसे लाया हूँ, ये डायरेक्टली नहीं आ गया, ये ऐसे आया है, पूरे प्रोसेस से आया है. ठीक है, तो हम ये कहेंगे कि द लोकस ऑफ द इंटरसेक्शन ऑफ टेंजेंट्स है ना, जिसे मैं कहता हूँ पोलर. इसे में हम क्या कहते हैं भाई, इसे हम कहते हैं पोलर. ठीक है, और जो पॉइंट P है इसे हम कहते हैं पोल. तो भाई ये हो गया हमारा पोलर का इक्वेशन. ठीक है, विद रिस्पेक्ट टू P. समझ आ गया होगा. तो आज की बस इतना ही. ठीक है, बाय. तो बेसिकली x1 तो हम इतने तक आ गए थे x(x1) प्लस, अब जैसे हमें h डैश k डैश में रिप्लेस करना था, सो y(y1) प्लस h y(y1) y(x1) प्लस f x प्लस x1 प्लस g y प्लस y1 प्लस c इक्वल टू 0। तो ये हमें क्या दे देगा, ये हमें पाथ दे देगा ऑफ दी बेसिकली लोकस दे देगा ऑफ दी इंटरसेक्शन ऑफ टेंजेंट्स। समझ आ गया? तो बेसिकली अब तुम अगर देखोगे, अब देखो इस एक्सप्रेशन को ज़रा हम इससे कंपेयर करते हैं ना। सॉरी क्या खुल गया, तो हमारा फिजिक्स का चीज़ है, सॉरी हाँ इधर पे। तो बेसिकली अगर हम इस चीज़ के लिए अगर हम देखें तो बेसिकली हमने लिखा होगा t इज इक्वल टू 0 विद रिस्पेक्ट टू p वाला कहा गया ये, हाँ t इज इक्वल टू 0 विद रिस्पेक्ट टू p। अगर आप देखते हो इसमें भी सेम ही एक्सप्रेशन है, एकदम सेम एक्सप्रेशन, ब्यूटीफुल सेम एक्सप्रेशन आपको दिखता हुआ इधर पे ही, ब्यूटीफुल एक्सप्रेशन आपको दिखता हुआ, ये सेम ही एक्सप्रेशन है। आप देखो सेम ही एक्सप्रेशन है, x(x1) प्लस y(y1), इसमें भी देखिए x(x1) प्लस y(y1), x(1y1) प्लस y(x1), x प्लस x1 y प्लस y1, x प्लस x1 y प्लस y1। सो बेसिकली आई कैन से दिस इज t इज इक्वल टू 0 विद रिस्पेक्ट टू p, क्योंकि p ही तो था ना x1 y1 जो कि मैंने इधर पे पुट किया x1 y1। समझ लो, मतलब इधर पे जो x1 y1 आया था वो तो p के वजह से ही आया था ना, वो तो p के वजह से ही आया था x1 y1। तो ये कोई पॉइंट था जिसकी वजह से x1 y1 आया था, और वो पॉइंट किसी p या a या जो भी हो जिसके रेस्पेक्ट में मैं लिख रहा था उसके वजह से ही तो ये x1 y1 ऐसे करके आया था। मैं जब t इज इक्वल टू 0 लिखता हूँ मैं हमेशा विद रिस्पेक्ट तो लिखता हूँ, लेकिन इस समय जब मैं कोऑर्डिनेट x1 y1 देख रहा हूँ मुझे पता है x1 y1 क्या है, हमारा कोऑर्डिनेट किसका है, हमारा कोऑर्डिनेट p का है। तो एक्चुअली ये घूम फिर के किस में आ गया, t इज इक्वल टू 0 विद रिस्पेक्ट टू p। इसका लॉजिकल रीजनिंग नहीं है, इसका ये रीजनिंग है कि मैं इधर से घुमा के ऐसे लाया हूँ, ये डायरेक्टली नहीं आ गया, ये ऐसे आया है, पूरे प्रोसेस से आया है। ठीक है, तो हम ये कहेंगे कि द लोकस ऑफ द इंटरसेक्शन ऑफ टेंजेंट्स है ना, जिसे मैं कहता हूँ पोलर, इसे में हम क्या कहते हैं भाई, इसे हम कहते हैं पोलर। ठीक है, और जो पॉइंट P है इसे हम कहते हैं पोल। तो भाई ये हो गया हमारा पोलर का इक्वेशन। ठीक है, विद रिस्पेक्ट टू P। समझ आ गया होगा? तो आज की बस इतना ही। ठीक है, बाय।